Welcome to Digital Toolbox. In this video we're going to go over making a quick, simple stair definition that's only based off of drawing a line from the stringer curve. So say I want to get to create a staircase that will take me to the top of this mass. I'll draw just this line from the ground up to one side of the staircase, and then I'll be able to edit the number of stairs, how deep the tread is, and how wide the stair is. But the angle is completely flexible, so then if I adjust this to a different volume, it will automatically fit itself. So let me draw a new line for a stringer for us. I'll move it out here. And then I'll pop up grasshopper. So there are going to be three inputs, and then the stringer curve. This is just a curve, which will be this one right here. So I'll right click, set one curve, and it's good to go. So that's already in there. And then we'll have three numbers. Number of treads, we'll divide it into 10 or however many divisions. Then the stair width, this is in meters, so I'll just say 1 meter. And then the depth, how thick do we want each riser to be. That's independent of the actual how many divisions there are. So we'll go ahead and start off and divide the curve. We're going to use just divide curve into equal length segments, so no matter what distance or height the stair is, it'll be equal no matter what. So you can see by default the number is 10. Take that, put that into our own, and then now you can see it's adjusting itself. So go ahead and leave it at 10. From here we're going to create a 2-point box. That's going to generate every stair actual tread for us. So we'll go under surface, primitive, and then box 2-point. This goes just like this icon shows, from one point to the complete opposite point of the box, and then gives us our geometry from that. So our first point, point A, we already have. It's going to be this curve point. So I can even put that in there already, but there's no other point, so I'm not going to see anything. The first distance I want is to move this point, divide whatever this vector is in the y-axis, and create that distance. So I'm going to decompose the vector of this line. Vector, it's under vector, and then it's one of these. So decompose, and then now we can see how many the vector for this line is 0 in the x, negative 4.7 in the y, and then 4 roughly in the y, in the z and in the y. So that y, since this is the y-axis, that's what we're going to stick with. So we want that divided by the number of segments, which is 10. So just go under math, division, and then a will be y, and then b will be 10. And that gets us roughly 0.4. So this distance will be 40 centimeters. Sorry. So we can even right click on this, and so we don't forget, we'll say stair depth or tread depth. Alright, and then we'll move this point. So just double click and go to move, or you can, it's under cross form, Euclidean, and then this is the geometry we want to move, is this point, and then we want to move it in a vector, the y vector. Go to vector, grab y, and you can see that 1 is too much. 1 is the default y vector. That's going to give us rather large steps, so we'll connect that to the tread depth, and then that is variable based on how many divisions we have. So it just falls right into place. So our next one will be the width. Before we even move on, we can take this move, our new point, and connect that into B, and then you can see that we have our that depth. It's not a full box, it's just a line right now. And then the next one will be a plane. So that plane, we want that plane to be the width of our stairs, and that'll be in the x-axis. I already have that here, stair width. So then I'll just copy this same move, except I'll connect it to this move, and then I don't want it in the y. So I'll disconnect that. I want it in the x vector. So I can connect that to stair width, and then you can see that it can move in and out as we dictate. And then I'll update my 2-point box, and here you can see that plane. So the plane is going to just on the stair width, and then however many divisions there are. And then our last thing to do is to give it some depth. So here's depth, 20 centimeters. It's the same story, just move this last point. And I'll move that in the Z. And then connect that to the B. And then there we have it. Here's our 2-point box. And we can adjust how deep it is, the width of the stair, and then how many actual treads there are. And now we can kind of fine tune it a little bit. Now that we have our geometry here, this depth, I don't actually want it to be a positive z vector. I'll go in here and set an expression to negate that. So I'll do -1 times f, commit changes, and that's just embedded here in the z vector. So now I'm actually going up to the same, it'll start and stop at the same level. And you can see that's kind of in the ground plane there. But now the real beauty is, I can take this and move it anywhere I want. I'll move it to this one over here, and then I can turn points on in Rhino, move this one vertically to the ground plane, and then I already have my staircase set up. So that's a quick and easy instant stair if you're still doing conceptual design or design development and you don't exactly know floor-to-floor heights or how large you want your stair. It's a quick and easy way to generate a quick stair.